This video, we want to consider linear inequalities with absolute values. So let's consider the following problem. 2x minus 3, all in absolute values, should be less than or equal to 5. This is actually a fairly complicated problem, and so let's break it down. Let's first take an aside. And in our aside, we want to consider what would happen if the problem had been the absolute value of x is less than or equal to 5. So clearly, since we're working with the number 5, we want to look at some places on the number line that are distinct. We would want to look at, up here on the number line, the number 5. But since we're working with absolute values, we should probably also consider the number -5. And we should pick things in between, like 0 would be a great choice in between. And we should pick things outside of that. So let's consider -10 and 10. So let's consider all of the numbers that where I've placed dots. -10, -5, 0, 5, and 10. And consider which ones make the statement the absolute value of x is less than or equal to 5 true. The absolute value of -10 is 10, and that's clearly not less than or equal to 5, so that would be false. Likewise, 10 has an absolute value, which is also 10, which is not less than or equal to 5. -5, on the other hand, has an absolute value of 5, which is equal to 5, so that makes the statement true. 5 makes the statement true as well. 0 is clearly less than or equal to 5, so that would make the statement true. So it appears that we have a true region in here. Let's consider two other points, -1 and 1, in that region, and see what they do. If I take the absolute value of -1, I have 1, which is less than 5. So we can say that -1 would make this true, and 1 is clearly less than 5, so that would make the statement true. So considering all of that, the region in between -5 and 5 seems to be the region where everything is true. So my solution is between the values of -5 and 5, so I would fill in with a solid line between -5 and 5. Notice there are solid dots at -5 and 5 because they are part of the solution. And 10 should disappear from the solution, as should -10. So what I have drawn now is in fact the solution to the problem, the absolute value of x is less than or equal to 5. Now let us go back and consider the original problem though. So when we have the absolute value of x is less than or equal to 5, it looks like x values that are everywhere between -5 and 5 work. So I could write that out algebraically as -5 must be less than or equal to x is less than or equal to 5. That corresponds to what is shown on the number line. We need to have something similar when we work through the original problem. So if we have the absolute value being less than a number like 5, then we know that -5 should be less than or equal to 2x. So if we go from the original problem, -5 should be less than or equal to 2x minus 3, which must be less than or equal to 5. Now it gets awkward to have two inequalities in the same problem. So here's where a logic statement comes in. We would say that -5 must be less than or equal to 2x minus 3. And since it has to be between -5 and 5, we could also say that 2x minus 3 must be less than or equal to 5. Now we can go ahead and solve this like we did other inequalities. We could add 3 to both sides and have that -2 is less than or equal to 2x. Divide both of those sides by 2, which is a positive number, so no problem there. -1 must be less than or equal to x. And if we come over to the other part of the solution, we would say that we could add 3 to both sides and 2x must be less than or equal to 5, divide by 2, and x must be less than or equal to 5 halves. Now let's take this expression and rewrite it. This inequality and rewrite it by flipping it around and say x must be greater than or equal to -1, but x must be less than or equal to 5 halves. So now, what does that mean? So if x were going to be greater than -1, let me plot it up here, it's greater than or equal to, we would have to be going that way. To be less than 5 halves, it's the other part of the solution, we need to be going the other way. So what is the solution? It's the region between -1 and 5 halves. How can we put that together as a single statement? Probably it's best to look at what we have right here and rewrite that as -1 was less than or equal to x, which was in turn less than or equal to 5 halves. So when we have an and statement, the solution is sandwiched between two values.